All right, folks, so resuming where we left off with the last video, we depressed it down to a quadratic. Didn't have to use the quadratic formula because there was no middle term, so moving the 2 over, square root, and x is plus or minus square root of 2. And again, as long as there's no I with it, you can check it on your calculator. So if I hit trace rad 2, boom, we get 0. Trace negative rad 2, we get 0 there as well. So lots of ways for checking yourself on this first section. That's kind of all the basics. Does anybody have any questions so far? All right, turn the page. It's fraction time.
Oh my God, I'm so excited.
On these problems, solving rational equations, first word of advice, you must factor fully. Let's write factor denoms fully. Factor the denominators fully. Beware negatives. Step 2, least common denominator, dynamite, where we blow up all of the denominators of our fractions. Next to number 2, state restrictions. State restrictions. And then number 3, check for extraneous solutions.
Is 6.2 just dynamite, right?
Yes.
6.2 is the hardest thing to do.
Wait.
6.1 was the operations. That was kind of the hardest section.
Oh,
This
we
section, no.
It's just easy. How do you pick which ones we're doing? Like,
We decide as a team.
yeah,
You get
arbitrarily, just like,
Yeah.
A plus on
Well, because these are the ones that are most important. So those who go on, this is stuff that's on the ACT. A lot of solving stuff is kind of the focus of term 2.
This one's not even that hard. You just have to like do it.
And folks, for checking for extraneous solutions, just put you can't divide by 0. And we check those against our restrictions. So we're going to start with number 14. Going through those steps. So if I told you to factor those denominators fully, can I factor x minus 3? What are you doing?
Can you? Yes, you can. You cannot.
Yes,
X minus 3. Go ahead and just trap it in parentheses. Can't factor it any further. 3. Can I break that down into, no, fire hazard. If it gets hot enough in there, sure.
We take them out.
So 3, can't factor that any further. What about 2x minus 6? It could be, I don't know. I've never done anything stupid like that before. Folks, can we factor 2x minus 6?
No.
yeah, you can't even
GCF! These are the ones to be careful of. Put a star by this problem. We're very used to factoring quadratics and polynomials and things that look factorable. But these simple little binomials that just have this sneaky little GCF you can take out, those are a little bit more elusive. So we take out a 2. That leaves us with x minus 3. And as you can see, this is important because now we see that these two fractions have an x minus 3 in common. So LCD dynamite time. We take the greatest amount of each item. So starting with the monomials, what's the greatest amount of 3's I have in each of these? 1. What's the greatest amount of 2's I have? 1. What's the greatest amount of x minus 3's I have in 1? 1, x minus 3. So our LCD is 6, x minus 3.
Because of math.
How'd you get 6?
2 times 3. So those monomials we have to take separately because they're their own factors.
Why is that not negative 3?
So that's the thing we were going to get to next, folks, is that minus sign. This was probably one of the biggest mistakes on this part of the test, kind of one of the only mistakes made in this section, was forgetting to float the negative up with the numerator. So turn it into a plus and float it with the numerator. That way it doesn't affect the denominator or any of those factors at all. So just shift it up to be with the numerator, also so you don't forget about it. All right, folks, so now for the restrictions. What is something x can't be equal to? Beth? Yeah, go ahead. Or what is something that would make those fractions dividing by 0 and thus undefined? 3. Because if I plug 3 in for x, I get 6 on the top. Oh, but 3 minus 3 is 0. 6 divided by 0 is undefined. Is there anything else that x can't be equal to? Nope. That's my only restriction. So it's important to state the restrictions on the front end. That way when you solve, x can be anything, but if it's 3, then it's going to be a no solution. So folks, now that we have the start of the problem, does anybody have any questions so far? Is this coming back to you a bit?
Yeah, a little bit.
So I am going to show the most work you could show on these problems, and then I think we'll do another one where I kind of show you the shortcut. What we do is the same thing we did to level out fractions in previous problems. So going back in time a little bit, if I have 1/2 x equals 6, what would I do to get rid of that fraction? Times by 2. That destroys the denominator. Now, if I have multiple fractions, like 1/3 plus 1/2 equals x, what I would do to level out those fractions is I would multiply by the dynamite, or the LCD, which would be 6. So that would cancel out with the 3, leaving me with 2. It would cancel out with the 2, leaving us with 3. So by multiplying by the LCD, that's going to wipe out every single fraction in the problem at once. That's why we call it the dynamite. So I'm going to lay down the LCD dynamite in front of my first fraction. So 6 times x minus 3. I'm going to throw it over 1 just because, make it look more like a fraction. And then times the first fraction, 2x over x minus 3. There's kind of my first block of work. Then I'm going to lay down another stick of dynamite in front of the second fraction. Don't forget that's a negative 1 over 3. And make sure you use the factored form because that's going to make the canceling out easier on these. So once we have this set up, it's really just a lot of cross simplifying and just regular simplifying. So what happens when I multiply this fraction by the dynamite? What crosses off? Goodbye, x minus 3. And what we're left with is 6 times 2x, or 12x. Moving on to the second box. What's going to cancel? The 3 cancels out with the 6, which leaves me with a 2, an x minus 3, and a negative, all being multiplied together. So I'm going to write negative 2 times x minus 3. Then, in our last block of work, goodbye x minus 3, we're going to take a 2 out of, you could either do that 2 or you could do the 6. We actually could have simplified that from the beginning. That leaves us with 3 and 2, or just 6. See if you can solve it from here. Distribute, isolate your variable.
Isn't it an easy way to do that?
No.
If I write out everything.
There's a slope faster.
Yeah. You're doing the same thing, but you don't have to write the boxes. You can just think of multiplying this by this, crossing off the x minus 3, 6 times 2x, crossing off a 3 from both of those, 2 times that, times the negative 1. So some of you will be able to do that in your head. I like to show all of the work just because I'm less likely to make mistakes that way. Folks, what does x equal? Is that okay?
No.
Yes.
Well, it could be.
Because it's not 3.
Correct. So because that is not my restriction, it's just about the denominator being equal to 0, not about the actual solution itself. X equals 0 is all good. Checks out against our restriction. Ah, I just tore my shirt. Let's go ahead and
People break it for lunch.
Mental math. Break.
get as far as you can on 15 with the LCD and the restrictions. And then we'll take it from there. What time is lunch?
12.
Oh, 12:15. Yeah, you know what? Let's just go ahead and start 15 after lunch. We'll go ahead and take 5.
Oh, let's go.